Academic search is changing, and it is changing fast. Today, we're taking a close look at a big new feature. EBSCOhost's AI-powered natural language search. But what's really going on under the hood? Well, thanks to a fantastic deep dive analysis by researcher Aaron Tay, we're going to pull back the curtain and see if this thing is a real leap forward or maybe just a new coat of paint. Let's get right into it.
So it all starts with something you're probably seeing every single day. Thanks to tools like ChatGPT, our users, and I mean everyone from first-year students to, seasoned faculty, they expect to ask full questions. They don't just type in keywords anymore. And what that means is that the academic platforms we all rely on are in a race to adapt.
But here's the thing. When we throw around a term like AI search, what do we actually mean? It isn't just one thing. So to really understand what EBSCO's doing with this new feature, we've got to get our definitions straight first.
Now, when you hear AI search, your mind might jump straight to Retrieval Augmented Generation, or RAG. That's the flashy tech that actually writes up a synthesized answer for you, complete with citations. But that's not what's happening here. We're actually focused on this second type, query translation. The AI's only job is to take your conversational question and, translate it into a structured command that a traditional database can actually understand. And that's exactly how EBSCO's NLS works.
So that brings us right to the heart of it. When a user in your library flips on that natural language search mode and types in a question, what is actually going on behind the scenes?
Turns out, it's a pretty straightforward three-step process. First, you type your question. Simple enough. Second, that question gets sent off to a large language model, specifically Anthropic's Claude 3 Haiku, which translates it into a classic structured Boolean search string. And finally, that string just gets run through the good old standard EBSCOhost search engine. So the key thing to realize here is that the AI isn't finding the articles itself. It's just a really sophisticated translator for the classic search system we already know.
And hey, just a quick point of clarification for you longtime EBSCO users, this new NLS is completely different from that older Smart Text search feature. Smart Text was more of a bag of words approach, just pulling out what it thought were important keywords. NLS, on the other hand, is a true LLM-based system, and it's designed to understand the actual intent behind your questions. Okay, so now we know how it works. Let's look at what it actually produces. Because when you put the Boolean queries that NLS generates side by side with its competitors, a really clear strategy starts to emerge.
And wow, this slide really says it all, doesn't it? For the exact same query about climate change, just look at the difference. Web of Science's tool explodes the query with tons of synonyms. Meanwhile, EBSCO's NLS keeps it way shorter, much more conservative. It's a completely different philosophy. So, why so restrained? Well, the answer really lies in EBSCO's existing strengths. See, the NLS doesn't need to generate a massive list of synonyms because it knows it's about to hand off that query to EBSCO's super powerful Unified Subject Index, or USI. The USI is already built to do the heavy lifting of mapping terms, like turning heart attack into myocardial infarction. The LLM just builds the basic structure, and then EBSCO's own subject mapping comes in and enriches. Now, this all sounds pretty great in theory. It seems transparent, it seems logical, but for any librarian or researcher, and especially for those of you involved in evidence synthesis like systematic reviews, there's one word that is absolutely paramount: reproducibility. And this is where the story takes a really interesting turn. I mean, on paper, the whole process looks totally transparent, right? NLS even shows you the Boolean query it generated. So if you have the query, you should be able to just run it yourself and get the exact same results. Shouldn't you?
Well, here is the core, baffling finding from the analysis. When NLS was given a query about open access citation advantage, it generated a Boolean string and came back with 125 results. Okay, but when the analyst took that exact same string and ran it in the regular advanced search, it returned 708 results. That is a massive difference.
The analyst, Aaron Tay, was pretty blunt in his conclusion. He said, quote, "In short, I am unable to reproduce the search most of the time." And for anyone who has to document their search process for something like a systematic review, well, that's a huge red flag.
But here is the really strange part of the puzzle. While the results aren't reproducible, the LLM's output is totally rock solid. The same search query produced the exact same Boolean string over and over again, across multiple days. Now, this is really unusual for LLMs, and it creates this bizarre contradiction. The AI's part of the job is perfectly stable, but the final outcome is a mystery.
So let's try to put all this together. We've seen how it works, and we've seen the puzzles it creates. The real million-dollar question for us as librarians and information professionals is this: should you actually enable it? Is it useful? On the plus side, you have to give it this: it absolutely succeeds at its main goal. It helps users who type in those long conversational sentences avoid hitting that dreaded 0 results page. It really gracefully translates their natural language into something the database can work with. And that's a clear win for user experience.
But it's not a true semantic search, because at the end of the day, it still relies on a keyword-based Boolean search. It can't always grasp the underlying meaning. For example, a search for a paper on open access citation advantage that used an RCT. It failed to find a key paper on the topic because that paper didn't use the exact phrase citation advantage. An embedding-based search engine might have understood the meaning, but this system couldn't make that conceptual leap.
So let's just boil this all down to 4 key takeaways. First, you have the conservative strategy. It leans heavily on the unified subject index, not the LLM. Second, there's that high stability. The AI's translation step is surprisingly consistent. Third, and this is the big one, the reproducibility issues. That final result set is basically a black box. And what that all means, finally, is that the marginal benefit is kind of questionable, since EBSCO's existing tech is already doing so much of the heavy lifting.
And that leaves us with a really critical question for the future of our entire field. This approach, using an LLM as a fancy translator for old-school Boolean search, that's one path forward. But is it the best one? Or would a true embedding-based semantic search, one that understands meaning, not just keywords, ultimately add more value for our users? That is the debate we are all going to be watching very, very closely.